Hello students, welcome to Saraswat classes. Now in this particular lecture we are going to discuss what is critical field strength, and it is also known as the crossover region, and it happens when the delta O is equal to P. So we have studied that for systems like D4, D5 and D7, they may exist as either high spin complex or a low spin complex, but such a thing is not possible for D1, D2, D3 or D8, D9, D10. There is only one type of arrangement on one way of filling up the d orbitals. So this critical field strength, wherein delta O is equal to P, also known as the crossover region, condition is delta O is P. Now for this particular value, what we can say is that below this value of delta O, wherein it is equal to P, all ligands will give you high spin complexes, and above which it will give you low spin complexes. Okay. So suppose there is a ligand whose crystal field strength is close to this critical delta O value or 10 dq value. Okay, this will give rise to spin state equilibrium. Okay. So this means what? That the difference between the energies of the spin states around a region which is known as the crossover region, which means this yellow line that we are seeing over here, the yellow marked region over here, this region, this is known as the crossover region. This region actually lies within the thermal range. Okay, so we would like to say the crossover region is in the range of thermal energy. So this means by changing the temperature, either of the spin states can be attained, or we can say the equilibrium can be shifted towards that. Okay, so as we can see over here that when the crystal field is low, we have the low spin with higher energy. Okay, and the high spin is lower energy. That means high spin is more accessible, but as we are increasing the field strength, that means we are increasing the gap. It crosses to this point. Low spin state becomes more accessible than the high spin state. Okay, that means as the energy gap increases. Now over here, it has been seen that as an example, we can treat this, that the iodide salt of bis 2,6 pyridine, dialdehyde, hydrazone, cobalt 2, which means it is a D7 system. Okay. At 80 Kelvin has the magnetic moment, that is the mu s value, which is given by n plus 2 bm. This is around 1.9 bm. Okay. So this is very close to 1.372, okay, bm. It is 9 because of some orbital contribution, okay, that it is higher than the spin only magnetic value. So we are not bothered about that. So basically n value over here is equal to 1. That means this is a, at this temperature it is a low spin complex, okay. That is what we have to understand. Now when you raise the temperature to say 337 Kelvin, mu s goes up to, which is again n plus 2 bm, it becomes 3.7 bm, which is very close to 3.87. That means here the n value is 3. So this is a high spin complex because only D7 high spin, as you can see. All right. So this is say D7, sorry, high spin. That means 1, 2, 3, 4, 5, 6, 7. So you have n equal to 3. For a low spin D7 system, you have 1, 2, 3, 4, 5, 6. So here n is equal to 1. This is your T2G EG. That is also your T2G EG. So this is one of the examples for a complex which shows spin crossover as the temperature changes, its magnetic moment changes. That means its n value changes. So if the n value is changing, that means from a 80 Kelvin when it is a low spin complex, and at 337 Kelvin it is becoming a high spin complex. Okay, that is what it means. Similarly, complexes of the type like tris alkyl dithiocarbamate, okay, iron 3, which is again a D5 system. Your ligand is basically something like that. Now over here, these type of complexes also are known to be showing spin crossover with temperature. Okay, so that completes this section, and thanks for listening. Keep visiting some of the classes for other sections of the coordination chemistry with many more examples. Have a great day.